In this lecture, we're going to learn about max element and min element algorithms. These are algorithms you can use to get the maximum and minimum elements from a collection. I don't think we need to do much more explaining here, but we can look at the documentation for these and you see that we have an overload that only takes a beginning iterator and an ending iterator. We also have an overload that passes in a comparator function that we can use to decide which element is greater than another, and this will look for the less than operator in the elements that you store in your collection. We have the same kind of behavior for min element, so let's look at a few examples. Here we have our collections, which can really be anything. We have a vector, a row array, and an std list. We're going to call the max element algorithm, and we're going to pass in the beginning iterator and the end iterator, and this is going to give us the maximum element, and that's going to be returned and stored in an iterator that we get here. So this algorithm is going to give us an iterator pointing to the element that was deemed to be the maximum element in our collection here. We have the same result for our min element algorithm, so we will have an iterator to the minimum element and we can dereference that to print our element here. But we have another version which also takes a predicate that will be used to decide which element is greater than other elements. In this case, we have a functor which is going to compute the distance from one element to another, and it is going to use this to decide which element is greater than another. So what we can achieve with this setup is that we can have a collection with elements inside, and we can ask our max element and min element algorithms which element is closer to a given number. For example, if we put in the 3, we can ask our algorithm to give us an element in this collection which is closer to 3. Or we can ask our algorithm to give us a number which is further away from 3 in this collection here. This is what we are trying to achieve here. We are going to pass in a functor which is going to compute the distance from one element to another, and it is going to use these distances to compare and decide which element is greater than another. Hopefully this is making some sense. So we can find the closest element by using the min element, because this is going to give us the shortest distance to a given element that we pass here, and we're going to be computing the distance to a number that we specify in this variable here. So this is going to give us the closest number to 67. We're going to print that here. We're going to find the number which is further away from the number in here, and we're going to print that right here. But it is also possible to use the min max element algorithm, which is going to return an std pair, and we can grab the result in a pair object that we use auto to deduce here. So the closest element is going to be stored in near, and the element further away is going to be stored in far, and we're going to print our data here, and we're going to see this printed out. If you have any problem with this example, please ask me. I will do the best I can to help you out. But the comparator that you pass as a functor here should have the ability to compare two elements that you store in your collection. This is the setup we have here. Now that we know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is max element, min element. We will grab the template files as usual, and we're going to put them in place and open this up in Visual Studio Code by dragging and dropping here. This will give us our main CPP file. Let's do the usual. We're going to clean it up a little bit. Close the left sidebar, and we're going to include our headers. We will need algorithm, and we need std set, and we need vector. This time we will be using list, if I remember correctly, so let's put in a list. We are going to head over in the main function and put in our collections. We can really use anything here. We have a vector, a row array, and a list, and we're going to try and get the maximum element. The std max element algorithm is going to give us an iterator to the maximum element, and we have the ability to dereference this iterator and get this element printed out, and we will do the same for the min element algorithm. We can pass this through our compilers. I just use Clang, but GCC is also going to work. Okay, the build is good. We can bring up a terminal window and clear and run Rooster, and we see our maximum element to be 400, which is what we have right here. You see, we are able to grab this maximum element with relative ease using this algorithm here. If you had to do this yourself, you would probably loop around in the collection trying to find the correct element. And if you happen to have different kinds of containers, you would need to set up different functions to find this maximum element here. So the algorithm library in C++ is really helping out here. We also have the minimum element, which happens to be the 3 here. And if we put in 123 here, we're going to see that this is going to be picked up as our maximum element now. Let's pass this through the compiler and play with us. The build is good, so we can clear and run Rooster. We see our maximum, we see our minimum. This is working really well. We can even change this to work with std vector. The requirement is that we have a forward iterator, which is going to be used to traverse looking for the maximum element or the minimum element here. Let's pass this through our compiler. We're going to use GCC this time. The build is good, so we can clear and run Rooster. We see our maximum, we see our minimum. We can even use an std list because this has a forward iterator. Let's pass this through our compiler and we can clear and run Rooster, and we see our maximum and minimum here. One thing I want you to notice and be careful about is the kind of iterators that are needed for these algorithms. For example, for the for each algorithm, we saw that we just needed an input iterator, but for our minimum and minimum algorithm, we see that we need a forward iterator, which can be used to traverse our containers. Sometimes you're going to have some limitations imposed on you because of the kinds of these iterators here. So you need to keep an eye out for this and make sure that the kind of iterator that is required is one that is provided by the container that you want to use this algorithm on. For example, here we need a forward iterator, and std vector has forward iterators, so this is going to fall in place. But sometimes this is not going to work if you try and mix and match iterators that containers don't support. Okay, we have our maximum and our minimum. Let's go down and put in a separator because we're going to do something else. We are going to use different versions for max and minimum here that take a predicate which can be used to decide which element is greater than another. We will set up a number that we want to find in our collection, and then we will set up a functor which is going to compare two elements by looking at the distance to this element here. So the lambda function is going to be stored in this variable here called distance, and we will use this as a callback to minimum element and maximum element. What this is going to do, it is going to find the closest element by using the minimum element, and it is going to find the furthest element by using the maximum element here. And we will note this in our collection, so we will be able to know which element is closer to 67 and which element is further away from 67. This is best explained by running this. So let's do this. We're going to pass this through our GCC compiler, and we have a compiler error. And what this is saying is that std list iterator int result. We have conflicting declarations for result here. Well, this is the problem. So let's take out the auto here because this is not a declaration. This is an assignment we are doing down below. But we will have to be sure that they are the same types. If they are not, we're going to have a bunch of problems. This is working fine now. Let's pass this through the compiler. And we're going to see that 71 is closest to 67 in our collection here. And it is the closest thing we have. And 400 is furthest from 67. If we change our number, for example, to 100, let's do that. Can we find it? We're going to change 67 here to 100. And we are going to pass this through the compiler again. Let's make sure we have our opening brace, and we're going to build again. The build is good, so we can clear and run Rooster, and we will see that 71 is still closest to 100, and 400 is furthest from 100. And this is really cool, interesting. You can really try and pass in any value here and you're going to see what you get. Another thing I want you to see is that we can use the min-max element algorithm, which is something we have right here. You can look at it if you want. And this is going to give us the minimum and maximum in one go. And we're going to be able to capture that information through an std pair object that is returned by this algorithm here. So let's go down and set up an example to play with this. We will capture the minimum and max in a pair object. And we're going to use the auto syntax here. So the minimum is going to be stored in near, the maximum is going to be stored in far, and we will be able to dereference these iterators and print our data as we see right here. Let's pass this through our compiler. The build is good, so we can clear and run Rooster, and we will see that we have the same data. This is working really well. You can use these algorithms if they make sense for whatever it is you are designing with C++. Again, as usual, make sure you come to the documentation and browse the entry for whatever algorithm you are interested in. This is going to give you all the information you need. We are going to stop here in this lecture. In the next one, we're going to learn about the find algorithm you can use to search for things in your collections. Go ahead and finish up here and meet me there.